Scientists are puzzled because Pluto really is a strange place. The strangest things found on its icy surface now tell a very different story. For a long time, this place was thought to be dark, lonely, and dead. But since NASA's New Horizons probe explored this icy world for the first time, our image of Pluto is changing. It's hard to believe, but this planet is now even being treated as a place with possible traces of life. Recent explorations of the dwarf planet Pluto have revealed a world of surprises and geological wonders. Impressive images from NASA's New Horizons mission and the latest analyses are now not only changing the way scientists see the planet, space enthusiasts and ordinary people alike are now looking at this world that is appearing before our eyes for the very first time. Before New Horizons, we had no picture of Pluto and what it really looks like. Even the Hubble Space Telescope only gave us a blurry photo of Pluto. The telescope simply wasn't designed to photograph small bodies orbiting the Sun in complete darkness. Fortunately, NASA decided to send its own probe to this distant world, otherwise, we still wouldn't know about Pluto's heart, icy glacier, snow made of nitrogen, and a lake. All the new discoveries show us a geologically active world. The image of dead Pluto is changing to a vivid vision of a planet that could be the messenger of a whole system of underappreciated planets in the outermost reaches of our solar system. We are only just beginning to understand this world and the world of minor planets in the Kuiper Belt. Liquid nitrogen-filled lakes, dynamic dune landscapes, and the astonishing activity of cryovolcanoes may tell us a whole new story of life that is possible even at the very edge of the solar system. Pluto was the smallest of them. Pluto, all in 1930, U.S. astronomer Clyde Tombaugh had the celebration of a lifetime. After decades of searching, he and his team finally discovered the ninth planet. For a long time, the planet which had to orbit beyond Uranus and Neptune was just an idea, a mathematical construct, and then it became the truth. Then came the shock. In 2006, scientists decided that Pluto was no longer a real planet and downgraded it to a dwarf planet. One of the reasons for this was the discovery of many other small planets orbiting even further out around the Sun. It was thought that Pluto and these many planets in an icy and dark world were not particularly exciting, but the astronomers were wrong. These dwarf planets may be hiding previously undreamt of secrets. Fortunately, NASA had already launched the New Horizons mission by this time. In the very year that Pluto was no longer supposed to be a planet, the probe set off on its almost 10-year journey far out into the solar system. In 2015, the time had come for the very first time we and the scientists saw what Pluto really looks like. It is beautiful, varied, and colorful. Experts recognized at first glance that Pluto could not be a dead world. There is snow, signs of ice volcanoes, and varied landscapes. The mission provided the first close-up images of Pluto's surface and was the turning point in the exploration of the dwarf planet. The complex and diverse landscape revealed a surprisingly young surface indicating ongoing geological activity. To this day, astronomers are analyzing the treasures of the New Horizons data and discovering more and more mysteries surrounding this underappreciated planet. The mission has sparked interest in further exploration of the Kuiper Belt. There are at least 4 other dwarf planets there that we may have underestimated, just like Pluto. We may even find further key information about the formation of our solar system. Snow. Here it is snowing nitrogen on Pluto. Can you imagine standing on a planet billions of kilometers away from Earth, and it's snowing there? The idea is bizarre, and yet it is somehow true. The snow-covered mountains on Pluto reveal exciting fluid cycles. The extent to which water, as we know it from Earth, is involved in these cycles is not yet clear. What is clear, however, is that water does not play a major role on Pluto, but nitrogen does. Most of Pluto's snow consists of frozen compounds such as methane, nitrogen, and carbon monoxide. At the extremely low temperatures on Pluto, and we're talking about around -30 degrees Celsius, these substances have similar properties to water here on Earth. The source of this snow on Pluto is most likely mainly its thin atmosphere of nitrogen, methane, and carbon monoxide. It's incredible that the minimal heating Pluto receives from the sun's far-traveled and sparse rays is enough to turn these substances into gases. Nitrogen, methane, and carbon monoxide then rise into the atmosphere and eventually fall back to the surface as snow. So, it's very similar to what happens here on Earth, except that the conditions in the outer solar system are more extreme and very different from ours. The question of what exactly the snowfall looks like and whether thick snowflakes also fall on Pluto is still open. At the moment, due to the extremely thin atmosphere and low gravity, the process of snowfall on Pluto is probably somewhat different. The snow could fall in the form of fine particles or as a kind of icy haze from Pluto's almost pitch-black sky. Interestingly, measurements from the New Horizons probe have shown that the snow on Pluto's mountains also contains water. At the extremely low temperatures on Pluto, water freezes about as hard as granite. The entire mountains could therefore consist of frozen water, and only the uppermost snow caps on these mountains are probably made of frozen methane, which is deposited on the peaks. The bizarre ice mountains on Pluto can reach heights of up to 3.5 kilometers and are similar in appearance to the glacial mountains on Earth, although their composition and formation is completely different. This world reveals a world that is somehow similar to ours and yet completely different. Methane lakes, rivers, and streams on Saturn's moon Titan. The Huygens probe discovered a similarly rich and Earth-like landscape. Scientists there have already discovered that the surface contains methane lakes and rivers. Pluto also appears to be a methane-dominated world. A mysterious lake was visible in photos and is one of the most surprising discoveries of the New Horizons mission. This lake is located in a mountainous region west of Pluto's large heart-shaped formation and is about 32 kilometers wide. The existence of such a lake, which exists at surface temperatures of around -230 degrees Celsius, is remarkable and raises many more questions about its formation and history. Scientists suspect that this lake was once filled with a liquid, which would be a truly extraordinary thing on Pluto due to the prevailing conditions and composition of the atmosphere. Scientists assume that only liquid nitrogen could have formed this landscape under certain pressure and temperature conditions on Pluto. Nitrogen can also exist in liquid form, in particular when the dwarf planet moves closer and closer to the Sun on its elliptical orbit and thus receives a little more heat. Nitrogen could liquefy and form a liquid lake at times. This means that there are seasons on Pluto with the corresponding geological processes and weather phenomena. In the Pluto spring, it is not the water that melts here, but the nitrogen. There is even evidence that the liquid nitrogen not only forms lakes but also riverbeds and canyons. All of this already paints a picture of a geologically active and dynamic world. The underestimated Pluto is proving to be a lively little planet that apparently still holds many secrets. Pluto hot inside. Is Pluto hot inside? It sounds amazing, but Pluto may be warm or even hot inside. This crazy discovery actually came about quite by accident. New Horizons had sent great photos of landscape-forming convection cells on the surface. A short time later, NASA once again pointed one of its best telescopes at Pluto, and lo and behold, the landscape of the cells has changed dramatically. This means nothing less than that material is being pushed in from below. But what internal processes can cause this cell and honeycomb structure to shift like sand dunes? Convection cells only form when a material or liquid is set in motion by temperature differences. In this case, the presence of convection cells indicates that something beneath the surface of Pluto's heart is warmer than the surface itself. This heat source could cause the overlying layer of frozen nitrogen to slowly circulate. The process is similar to the convection that occurs in liquids or gases when they are heated unevenly, such as in a boiling liquid or in the atmosphere of a planet. Interestingly, icebergs or larger blocks of ice appear to collect around these convection cells, suggesting that they are pushed to the edge of the cells by the underlying forces. The discovery of convection cells on Pluto is a significant indication that the dwarf planet is far more geologically active than originally thought. The discovery is another fascinating puzzle that Pluto now presents us with, and the data from the New Horizons mission can only be the beginning. Gigantic dunes wander across the surface. Pluto is a dwarf.